Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video. And today we're going to talk about hydroboration, oxidation. But before we do, go ahead and slap that like button, leave a comment down below, and subscribe to my YouTube channel. It really is helpful when you do those three things. So go ahead, slap that like button again, leave a comment again, and go ahead and subscribe to my channel. It really is helpful. Share my content with your family and friends. It helps me grow my channel and gets me out there and helps other people learn organic chemistry. Let's get into this. Now, you're going to see similarities here also with chlorination and oxymercuration. There's similarities. Not the same. Similar. There's similar ideas, similar motifs, if you want to say it that way. Similar arrow pushing. Same game, different players type thing. So let's go with the mechanism. There's my starting material. It's just an alkene. Don't think of it as anything more than an alkene. Now, borane, BH3, is electron deficient. All right. Now, borane is electron deficient. It only has a sextet. So it's going to get attacked by something. Something is going to attack the boron. Now, that something is the pi bond, for sure. So the pi bond is going to attack like so. This arrow is telling me that the pi bond is going to attack the boron, and the boron is going to get stuck or bonded to this carbon right here. Now, at the same time, a hydrogen or a hydride is going to attack that carbon. So, in a concerted fashion, at the same time, at the same rate, as this bond is forming between this carbon and that boron, the hydrogen-carbon bond is forming here. Now, the interesting thing about this is all happening at one time, and it's all happening on the same location. What do I mean by that? I mean that double bonds are flat, right? You guys all know that. They're trigonal planar. They're planar. They're flat. So the boron, if you want to think this white pen here is my boron, it can come in from on the bottom and get attacked from the top, or it can come in from the top and get attacked from the bottom. It all happens on one side, though. So if the boron comes in from the bottom, everything happens on the bottom. If it comes in from the top, everything happens on the top. So what does that mean? What's the result of that? Well, the result of that is this. Watch this. This is pretty neat. So now the hydrogen that came from the boron and the boron itself are both down. Now I drew them both down. I could have drawn them both up, and the methyl down. I could have drawn the enantiomer. I, for whatever reason, like to draw my stuff being at it going down. This is something I've done since I was in undergraduate like you guys. So, but remember, even though I've drawn them both down and this one up, I could have done the opposite. This one down and these two up. I could have done it that way too. There's nothing wrong with that. Okay, now, that ends step one. Now we have to do step two. Now, step two, you have to understand, first of all, that this is basic peroxide. So when you have basic peroxide, you have to understand, first of all, that you can deprotonate it. That's the first step in part two. Hydroxide will deprotonate the proton. And it makes an anion of hydrogen peroxide. Who knew you could do that, right? Kind of neat. And this is going to come down here. They're going to collide. So now the basic peroxide from here. Oh, before we go on, I should mention real quick. Notice that there's 3 hydrogens on the bromide, on the boron, right? And I showed you one pi bond adding to the boron like this. There's still 2 hydrogens left. This can actually happen 3 times. So this can add. Then another one of these can do it to the other hydrogen, and then the other hydrogen. So you could end up with this boron with 3 of these cyclohexane rings attached to it. In fact, you probably do, okay? I don't draw that, though, because then the drawings get really complicated. So what a lot of folks do is they'll do it once, and then they'll just say R groups here. to let you know that these cyclohexanes have added 3 times to one boron. Just so you know that happens, okay? I didn't do it here because I don't want to get too complicated, but you have to understand that's what happens, okay? So just keep that in mind, please. So you know what? Let's just do it. Let's just call these R groups times 3. Let's just say it happens times 3, okay? Just to make everything cool. So now, at this point, the boron will get attacked. And that will give us R and R. Remember, R is just this. Okay, it's just 2 more of those. But we're only gonna work with 1, but it happens 3 times. Everything I'm doing here happens 3 times. Just remember that. Okay. So now we're going to have an oxygen, hydrogen, all right. And now in this step, this bond here is going to do a migration. So watch what happens. And attack. Let me use a different color. Let's use magenta. Let's use red. Attacks this oxygen here, and this goes off as hydroxide. And you're going to get
like so.
Which now at this point, the hydroxide will now add back. And you can think of it perhaps as a SN2-like mechanism where that will leave, forming the product. Which would then get protonated when you add some protons in there to finish up the reaction. And remember, you get both enantiomers of this. So here I'm drawing 1 enantiomer. Of course, you're going to get another one. Plus the enantiomer. All right, so this reaction is a little complicated. It's probably one of the more complicated ones we learn in organic 1 or intro to organic chemistry, but it's not that hard. It does follow along with a lot of the ones you've already learned. Most of the complicated stuff happens right around here towards the end of the mechanism. So it is what it is, guys. You got to learn it. You got to know it. And most faculty ask it because it's a complicated mechanism, and we want to make sure you're paying attention. Sorry, it's kind of how we are. So please forgive us, but you know, we're just trying to get you to the point where you know organic chemistry like as well as we do. 5, 4, 3, 2. So that's the mechanism, guys. I know it's a little bit complicated. It's one of the more complicated ones we learn in organic 1. So don't let that phase you. Just learn it. It's not that bad. You have the ability. I know you can do it. So just get after it. And with this, guys, I want to say thank you for watching this video. Hope you found it helpful. If you did, slap that like button, leave a comment down below, subscribe to my channel, and share my content with your family and friends. Let them know there's help out there available if they should need it. And with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.